Hello everyone, I'm Longpan. I'm an assistant professor at National Taiwan University. I'm presenting Reality Rift, Wonderful Interfaces by Disturbing Perceptual Causality. So here's an example of the Reality Rift. The user turns on the faucet and sees the wheel spinning, as if there's water flowing out and driving the wheel in different speed and directions. So the key here is that the system behaves physically plausible explicitly without water. This guides the user to naturally imagine the missing water flow and thus elicits a sense of wonder. Right. Talking about wonder, there has been a long philosophical discussion about wonder, which can be dated back to Aristotle. He said, "It is through wonder that men now begin and originally began to philosophize." And in terms of interaction, before we philosophize, we explore our physical reality by interacting with objects and observing phenomena with different sensory cues like visual, auditory, and haptics. We then form expectations in our imaginary reality from the perception of causal relationships between observed phenomena. And this is the stage where we feel a sense of wonder. However, we no longer wonder once all observable phenomena match our expectations. And with media technology like language, text, image, etc., we create virtual realities to convey our imaginations. However, since anything may happen in the virtual world, we suspend our disbelief, meaning that it does not change our fundamental beliefs in the real world. And with computing machinery, we are able to not only observe more in the physical reality, but also affect it. And as computing machinery gains more control over the physical reality, for example, programmable matters, new fabrication machines, metamaterials, etc., we can create an interface to induce a sense of wonder and make the user believe the new reality. To induce a sense of wonder, we borrow the concept from Anders Schinkel, who says wonder thus implies a shift in perspective that is particularly manifest when something ordinary is suddenly seen as extraordinary. So the key idea behind reality rifts is to hide certain physical components in an imagined reality. In other words, they only exist in the imagination and are invisible. In the meantime, the remaining physical outcome still happens in the surrounding environment, making the user feel something ordinary is suddenly seems as extraordinary. And here's another example of a reality rift. The user loads and launches the catapult. And even though there is no projectile, the water in the tank still splashes, and as if there's a projectile being thrown into the water. And here's another example. And note that the fan is not powered, as you can see the blade is not spinning. But the wind fan is still turns just like there's a wind blowing it. And here's another one. And here we use flameless lighter, by the way. And so this example also showcases the simplicity of creating a reality rift. Right. So, hiding more components yields lower levels of affordances, but more general to be used in multiple scenarios. So you can see here the general stick can be used as a screwdriver to screw the screw. You can see the motion of the stick actually corresponding to the motion of the screw. And here we can use that as an axe to break the wooden plate. So we have shown 6 characteristic prototypes of reality rifts. Now let's talk about how to open rifts in reality. So to open a rift in reality, we target a physical interaction and convert it into a causal graph. So all interaction starts with the user input and end with observable effects to match the user's expectations. In between, there's a sequence of intermediate phenomena that the interaction can be further broken down into. And by selectively hiding one or more intermediate phenomena, we can test to which extent the user still can recover the original cause of wrath. And in the meantime, we have to find an alternative cause to achieve the effect without being noticed so as to maintain the original causal impression. And let me use our catapult as an example. So the user input here is to spring load the catapult, and the intermediate phenomenon we want to put into the imaginary reality is the appearance of the projectile. And the final effect is the water splash. And we use an air compressor to burst out an air bubble from the bottom of the water tank to simulate a splash. And we described the complete 3 steps of opening up reality rifts in our paper. Here I'll just quickly run through it. So the step 1 is to pick a causally perceptible interaction. And we use spatial and temporal contiguity to pick up a causally perceptible interaction. And in short, more mundane interaction is more causally perceivable. And step 2 is to disrupt perceptual causality by hiding phenomena. In our prototypes, we hide the object's appearance as it directly infers the existence of the object. And step 3 is to restore outcome by alternative systems. And here's an alternative system you just saw for simulating water splash, and more details you can find in the paper. So we wrap all 6 reality rifts prototypes and their baseline counterparts as a 1-week preliminary field deployment in a local escape room studio with 50 participants. And here's a short clip of our deployment. Right, so we ask participants to pick their most wonderful and wonderless interaction in reality rift. And these results support our hypothesis of the wonder clarity spectrum. And you can find the spectrum in our paper as well. And we also compared it with the baseline condition where everything was revealed, and reality rift did generate a more enjoyable experience and trigger more user curiosity than the baseline condition. Alright, so I would like to talk more about the insights we found in doing this project. The more realistic simulation and perfect camouflage, the more technical limitations to realize reality rift, similar to all the mixed reality technologies. For example, a better implementation of our wind fan would be to only hide the wind in imaginary reality with the fan powered on and spinning as normal. And this will be difficult to achieve because the blade of the fan need to be balanced in order to achieve the least aerodynamics. And while there are physical constraints, we see that the reality rift inspires new technical challenges to connect sensing and actuation systems. And reality rift decouples original causes from their effects and opening up a design space for systems that simulate effects while hiding alternative causes. And with more and more new sensing and actuation technologies being developed in recent years, we see reality rifts as a source of inspiration for reimagining new physical displays that gain control over physical matters. And finally, I would like to bring it back to the beginning of the talk. We have explored reality rifts using computing machinery to create a physical interface to induce a sense of wonder and bring the user into the new reality. And our 3-step process eventually comes down to understanding deeply the user's perceptual causality and the noticeable of the new imaginary reality, and the technical challenge in simulating facts and camouflage the alternative sensing and actuation system. So I hope this paper makes you wonder about the next new reality and the new tech within your own perceptual causality. Alright, so I would like to thank my lovely students Chen, Yi-Hao, Elise, and Yi. And I would also like to thank Enderspace for lending us space for the field deployment and providing feedback. And also thanks Christian from ETH for chiming in for the last couple of months. And thanks everyone for listening.